Um, Today we're going to talk about the mathematical properties of ancient symbolism and how they translate into our modern understanding and vocabulary. Um, kind of doing this off the cuff, just off the top of my head, because I've been trying to figure out how to format it for a long time, and sometimes it's best if we just talk, right? So we'll see how far we get with this, and then we'll move on to the next things. First, we need to start with trigonometry. Okay, trigonometry is the branch of mathematics concerned with specific functions of angles and their application to calculations. Um, and this is important because, as we'll see when we start diving into some of these shapes and their angles, why this is important. Now, there's 6 functions of an angle commonly used in trigonometry, and their names and abbreviations are sine, cosine, tangent, cotangent, secant, and cosecant. Ready to go. Sometimes I get a little talking a little fast and I get a little confused in my verbiage. Um, Please gently correct me or uh, let me know if I've stumbled a little bit because it's a lot. It's a lot to consider. So when we talk about these conversions of how triangles are used within a circle, right? And each of these is a right triangle. All right, let's try this. So we'll go here first. So if you have a circle has 360 degrees, and there's lots of ways of finding triangles and dealing with angles within a circle. These are some examples. We're not going to have like a total math lesson. That's not exactly what this is about, but this is each color coded. So these blue ones are all the equivalent of each other. This is equal to this and to this, okay? And it's translated that way throughout this entire chart. These green angles are the same. These red, well, they're curves, but they're the same. All right, and so this is just like the basic uh, diagrams of um, of trigonometry. So why are we even talking about that? Well, let's talk about um, angles, right? So we'll talk about a gnomon. A gnomon is the part of the sundial that casts a shadow, um, and they're often just like a stick in the ground, right? So when we have this shadow, this stick casts the shadow on the ground according to what time of day it is, and we can calculate um, east, west, north, and south, and how much that angle has changed throughout the day, and it falls on a curve, right? Here's some ancient Gnomon timekeeping tools, right? Stop, stop, stop. Hours, hours, hours. There was a really cool one from above the Temple of Delphi that I really loved. But here's another one. This is like ancient clock, right? Babylonian ancient clock. Now keep in mind that there's numbers here. There's a sundial here, but there's also some graphic on the ground here. All right, because this is the way that the shadow casts. It does cast on the surface itself, but it casts on the ground, and so this is how we find distance. This is how we calculate what time it is. This is pretty basic stuff, right? So when we incorporate a gnomon, our trigonometry, and this little bit here called the analemma. The analemma is the kind of crazy eight shape that the sun and moon and stars and basically all of them make in the sky as they traverse their paths. And they do this because we are on an angle and so are they, and the relationship between the two things has kind of this cyclical, almost like an infinity sign, right? So when we put a stick in the ground, pretend that this meridian here is a stick. And we use it to watch the analemma move, or the shadow of the sun move. It will cast an analemma into onto the ground. And just bear with me, we'll find out. I appreciate you guys' patience. This is just one of the easier ways to do this, maybe. But anyway, when we take the analemma and we put it on the ground, from a single point, we can begin to see this is from the Celtic Druid temple, and I've just overlaid a few of these torques over the top of it, these necklace pieces here, to kind of highlight, okay, so here's the center point. If we put a stick here, we would be able to watch the shadow move, and we would know exactly, this is the sunrise, this is the sunset, and this is high noon. And from there, we begin building. We start showing some stuff. And it's basically, I mean, I hate to say, like, basically that's it, that's all, that's what it is, but when we get down to brass tacks, that's where it begins. It starts with a single stick and the analemma. Now we've talked about, the gnomon. So here's this clock here, right? That clock looks an awful lot like this, all right? And it also, here's a clear shot of it. Oh, I guess not. Let's try to make it bigger. But this from carolkill.com, and these are some of the drawings that were placed over them um, by see what I'm talking about when my head is in one place, other drawers don't open. Here we go. Here's our analemma. So this is a trek the sun makes across the sky, or the moon makes across the sky in its 28-day moon cycle. It's half of an analemma. When we put it on top of itself, it creates an entire analemma with these weird little ears, almost like horns, maybe. So you can see I've just superimposed this image upside down on top of itself. Here are the mountains. This is the same moon. This is the same. This is the same moon as this. They're just superimposed to create this. And we'll get into the 57.3 angle in a little while, but it's extremely important. In astrology, we talk about squares, sextiles, trines, things like that. When we talk about ancient understanding of science, we need to be able to use these terms interconnectedly. We need to be able to say sextile is 60-degree angle. And that's what it is, no matter which way you look at it. But we don't use the term sextile when it comes to uh, the astrological implications of that when we're speaking mathematically, generally, right? Um, in astrology, there's also something that's called an orb of influence. It's anywhere between 2 and 4 degrees outside of the vector. So if you are, say, at 60 degrees, you might have an orb of influence of about 4 degrees. So 4 degrees on either side could be influenced by the behavior of that particular sextile. If we consider 57.3 degrees within the orb of influence of a 60-degree sextile, this becomes very interesting, as does the secant, which I'll show you in a minute. It'll probably pop up here. But can you, I mean, that's pretty crazy. This 57.3 degrees just gets um, it's like universal. This is the hot number here. Now here's the 28 secant, right? So the 57.3 degrees is within the circle. The 28 degrees is on the outside of the circle. Now that's still 2 degrees within the orb of influence of a trine, 30 degrees. Um, and so things can start to get really confusing because a lot of these are just images that I started to superimpose. This is from one of Sean's drawings, and I've just put it on top. I like his drawings because they're extremely well done, and they add a spatial parameter, a visual spatial parameter that we can actually measure things by. It's real geometry. And so here, interestingly enough, we wind up with this little pentagon right in the center with a pentagram, the pentagon, and turns out it's just a bunch of triangles. Okay. So that's what we talk about when we get simplicity. So here's a couple more Sean's drawings superimposed on top of this to kind of just measure, right? How are these things behaving within these parameters? And it gets really, really interesting the way that they sit on these angles. So I had to find out more, right? Because if we take the analemma, right, and which this is the solar analemma, and we put it on top of the lunar analemma and all of this crazy mess here, it continues to carry throughout. So if you think about these moving objects, right, as teeth in a gear, cogs in a gear, you have to have so many cogs in the smaller gear for it to function properly with the larger gear, and that gear is theoretically or probably connected to something else, right? So how do these gears interact? And I've always kind of visualized it as gears and a sewing machine. So you'll hear me talk a lot about that, about stitching and how they all kind of fit in. So when I put them over top of each other, of course, here we go, uh, a ratio of 20 teeth to 40 teeth, which is, double. Well, fits in there quite nice, doesn't it? Gets really weird. And then I, of course, had to make it a little bit. What I was trying to do was try to make it just a little bit easier to read. I mean, look at where they meet. The measurements of this is just a little outstanding. I kind of get overwhelmed by it. So, like I said, I am your tangent. I go off on them frequently. So, when we put all these things together, if you think about like how things are measured, where we sit on our planet, where our station of observation is, how all of these currents kind of interact and move with one another and move through, and how they're ratioed, just in general, how those ratios all kind of relate to one another. Um, they're all the same. So if you find one, you've basically found them all. And so here's the next in relation to this specific thing. But I think like what the ancients knew that we're having a hard time understanding is that the basic parameter applications are the same. The functions are the same. I get a little upset when people say this is everything is this, right? Well, yeah, everything is that. Everything is something, matter, right? But what is it? We don't know. Basically, there's two things that we can break everything down into, and then how do those two things work? And that's electricity and magnetism. Now, electricity is the force, magnetism is the field. So you have a force field. They run perpendicular to one another. So, say the magnetic field is going along this axis, the electrical field would be going along this axis. And when let me get out of here. When a charge is induced, here we go. Okay, so there's electrical potential. So here's the electric field running perpendicular to the magnetic field. All right. Um, and the amount of charge induced is in relation to that space between that 90-degree angle, right? How much charge is actually moving through there before it's dissipated, right? So increasing magnetic field, increasing energy, right? Um, People are going to yell at me about all of it. So I'm just saying what I'm saying, and you feel how you feel about it, and that's just fine. Um, we're all working together here. Remember that. So, oh, good. I was trying to find the sticker because I had to turn it upside down. So here we go. So as these two things spin and interact with um, this plane here, see, I need to get it better. I need to find the sticker. Charge is induced, right? And it keeps going. It keeps spinning, and so it winds up being in this undulation of waves, charge up and then a rest, and then charge up and then a rest. And the amount of that, the value of that is the value of the induction of charge. All right, which I've overlaid here. This is a curbstone from Noth, from the Brún de Boyne in Ireland, and it's probably my favorite by far of the megalithic structure sites. And it's because it is, in my opinion, the oldest school on the planet. You want to talk about old school, you talk about old school. Uh, but maybe they do get older. I mean, I talked to Laird Scranton a lot about the Dogon and about the um, Scair de Bray in Orkney, Scotland, and he also feels the same, that these are ancient schools of physics, ancient schools of natural sciences. All right, so the things we find in these ancient sites will tend to be similar throughout the entire world. Everyone knew these things, just like we all know this stuff now that we know. And so basically, if we just give them a little bit of credit and say, they were intelligent human beings who are capable of understanding what they were looking at, just like we would hope we are, um, then we could say that this is their handling of those observations and that they are in no way less than our understanding. If anything, they had a much greater understanding of how these things worked, and they wrote these for us. So yes, while this curbstone is probably a sundial, it's probably a clock. This These are supposed to be moon cycles. There's supposed to be like so many months in here and all these things. But when I look at all of this, what I see is sine, cosine, tangent. What I see is sine waves. What I see is a gnomon in the ground predicting the angular movement shifts of two spherical bodies interacting on a plane. And those spherical bodies interacting on the plane cause a charge differential as their movements shift. All right. So they left us all of this information for us to look at and see. But we kind of look at it from our own angle, right? We look at it from our own view and our own eyes because we think that the Greeks created all of this information, but the Greeks will tell you they got it from Atlantis, right? And I know it's not exactly the most popular idea right at the moment, but I'm with Anthony Woods on this, and that if we were going to call anything Atlantis, it might have been Ireland, or Ireland might have been a portion of that great lost civilization, because th- these are very advanced formulas. These are very, very um, thorough understandings, which take time. They take time. And I wish I could say that I found something different in these, because at first I thought that they were just plasma vortex descriptions, which of course they are, because plasma vortex descriptions, charge differential, all of those things are in direct relation to what? Trigonometry, calculus, sine wave functions, right? And so, of course, they're applicable. This is a page from the Book of Ballymote. This is the Ogham tracks, the Ogham Few. This is the ancient Irish alphabet. And basically, these are mathematical diagrams. What happens when things interact in these capacities, and how do we break them down, right? And we know we know certain things. We know that at a 90-degree angle within the circle, you get a charge. And if you divide that 90-degree angle in half, you get a 45-degree angle. And then what happens? There's like a coupling here. right? Internal, external. Like I said, I'm not super organized on my presentation here. Just kind of off the cuff winging it. This is called Fion's window, and I've superimposed these sine wave functions on top of it just to get a measurement of where these placements lie and how they interact with these fields. Now, it must be important to note that this alphabet was originally said to come from the 4th or 5th century, but they were on stones from before then. And then they had to be learned by Irish monks, had to memorize that page from the Book of Ballymote that I just showed you. They had to memorize all of those. This is supposed to be an alphabetical, readable lettering system. And there's one, it's my favorite. It's like the Ogham Tract 35 of Anger and Uproar, because anybody trying to read anything um, written in this alphabet is sure to meet with great frustration. And I can see why, because you know why? Because this is math. And if you read it as math, it's so much simpler than reading it as an alphabet. Please don't think that the things that I'm saying take away from years and years and eons of learning and descriptions and understanding of what these symbols mean. They still mean all that too. Let's add this to that equation. All right, let's throw this in the pot with them. And as a matter of fact, I would say that this is the basis of all of it because mathematics is the universal language. It doesn't matter what verbal language is being spoken. When we show people equations who understand equations, or when we present numbers in math, that's something that is universally understood throughout. Or is it? Well, if you don't use numbers and instead you use dash lines and how they relate to a plane, well, they can become all kinds of things, right? And when we put them together and have them interact with each other, suddenly you become a recirculating charge. You have everything kind of feeding itself in motion here. And it's really, really interesting. Now, we can talk about radio devices and how all of this equates into that at some point. If you've ever looked into my work, you know that's what a lot of it is about. But here is the inside of a passage tomb, and it looks a lot like a church, right? So we're just going to call them cairns because I'm not particularly fond of passage tombs. So we'll go back here real quick. This is the inside of the tomb, right? And so we have a cross section like this. Here's east, west, north, south, all right? Slight angle, just like the pyramids. And there's cross section, what's in the center of the cross section, pretty evenly distributed. And then when we add on top of it our ecliptic diagram where we have the sun's motion moving across the horizon every day, and we put ourselves in the middle of it, this kind of becomes a tube um, where all of the circulation of this energetic charge can kind of move through. And then look at that, it's almost like a lens. And then it bounces back down. And the function of that we'll discuss later, but for right now, I'm just trying to illustrate the basic point that these were very, very well thought out and meticulously recorded informations because, I mean, look at this. I actually have this as my screensaver, one of these as my screensaver, and the things that I found in it. I invite you to pick a picture, any picture, a picture you like of something of this nature, and just look at it. Just look at it. Watch how it interacts with itself. Here's some weird ones of Avebury and Gagule Tepe. You guys know I have the worst time saying that, but there is something before we. Here's the breakdown of these angles and how they relate to the shift. Now, if we look at them, This is from my. Look at those triangles. Look at that angular momentum shifts, right? This is about nowish. Well, actually, like we're like right in here today. Um, but these are all interactions. This is the Druid eight wheel of life. In the center, we have the grove, and then uh, autumn equinox, spring equinox, summer summer solstice, winter solstice, and they kind of coincide with these movements that we talk about of which way the charge is moving. Charge is moving in these spirals. Well, it goes up. Sometimes it goes this way toward it, and sometimes it goes winder shins around it, you know. So that's going to determine which way the flow from the vortex is moving. And when we start really interacting with it, it gets really, really, really weird. It gets really, really, really weird. So we'd like to break them down for you, but word actions. Here's these ones at my conversation with Rob and Edgar about these stones at Long Crew. These original pictures are from Anthony Murphy, Mystical Ireland, um, and uh, looking at them, I was just so taken back because it's like, okay, 13, 13 moons, eightfold wheel, all right, sun's rays. Some of them might have been stretching. 10 days. Originally, weeks had 10 days, right? 9 rays, night, dusk and dawn. Got the summer equinox. Got magnetic fields. Got solar interaction. You've got all of these things going on um, in this symbolism that winds up showing out. So this is the earthquake detectors because when you start applying it to the earthquake phenomena, you wind up getting this. Interesting. So here's Ogham. One. Here we go. So I started putting them together, which letter is doing what here? What does it mean? Okay, well, this is downward, right hand represents air, downward, downward, upward, downward. Well, they're showing interactions with these planes, right? And how are those interactions um, effective when we start looking at these things and which way these things are moving and how they break down into these cycles and what they mean and where they go when they start to interact with each other, and you wind up getting trigonometry. I mean, there's Randall Carlson. Here's my friend Vanessa that is a math teacher, and she was kind enough to do this little trig lesson for us over some cheese and wines so that we could kind of verify that in conversation that not only is this possible, but it's applicable and being proven more and more by this work. How all of these function, and then I gotta play with them because I'm a crazy weird artist. Here's this last part that I'm going to show you for this weird little chat that we're doing now, um, because it's actually the most interesting part of this little chat. There's a lot of interesting parts. Here we go. So here we go. It goes around in the wheel. All of this is moving through the earth. Here's all of our functions. You see how they're set up? I can't remember who this came from. Came online. And I started mapping them around these solar halos. And when I did that, I realized that, and put them overhead. See, this is the underwater. This is the Great Lakes. Stonehenge that lines up exactly with the regular Stonehenge. These are from Crichton Miller's book. Here we go. Here we go. This is the Church of the Holy Sepulchre in Jerusalem. And it's very similar in a lot of ways to a lot of these dome structures that we see. You've got a dome coming in, you've got the light coming down, you've got all these little windows here. Yeah, domes are the strongest thing. Look at all these stars. Structurally, the domes hold up the sky. The sky's a dome, right? So here's another one of Sean's drawings over it to measure kind of how all of these things are placed. I love how it's like this little ball of light comes down and then these things circulate it. Why is this important? What does that have to do with anything? Well, when you take the stick and you put it in the ground and the light starts to show and you can begin to see what time it is. You can begin to see what time of year it is. You can kind of get an idea of where things are on the planet and further out in space because you have a trigonometric function to calculate these things. And so eventually it all starts to make sense, and what was so far away isn't so far away anymore. So we take the Church of the Holy Sepulchre and we line it up. It's in here somewhere. Hold on. Because we line that up with some of these circular calculations, and I don't want to say it before I show you. You're probably already picking up what I'm putting down. Now here's some graffiti, medieval graffiti, and people are like, "What is this? We see this all the time." Well, doesn't that look a lot like this? Well, see, that's what happened. I actually put them on top of each other here. They're like a little bit difficult to see, but I took those two images and I superimposed them on top of one another. There we go. This one, this one, this one, and this one. Now, now here it is. It's right here. Exactly. Because um, now we know what time it is. We can tell by which way the light is shining on the walls through those windows. We can tell what time it is. I'm going to show you this other video real fast, like a short little weird video. Um, because this is our state capitol building in the state of Michigan. Looks a lot like many state capitol buildings. On the bottom floor, on, on the main floor underneath, you have a, what is that? Oh, what is this? It's a compass. Very interesting. Very interesting. And then you get this dome on top. And it looks just like, but this isn't a church, right? This is the state capitol building. And I wanted to capture something in light while I was here because these lights, they come through and they shine, comes through these different windows and they shine at different angles, and as the angle comes down it falls on the walls and it tells you what time it is. It tells you what time of year it is. It tells you where you are in the solar system. um, you can look out the windows and you're like standing inside of a gauge. Oops, look at the light. Boop. Listen, yeah, look at the light. Look what it's doing and look how it interacts with these domes. And then there's these little figures that are evenly spaced. They go around the dome and they continue to do this throughout the bottom all the way to the top. And with each angle, you have a new unit of measurement and the light comes through and you can gauge where you are, how far you're going, how far you've come, what time it is, where you need to go next. You can begin to really get a good measurement of things that weren't available before clocks. Anybody can stick a stick in the ground and turn it into complete universal understanding. You can start begin to measure these things in this way, and they all knew and they all understood. that this is how you do it. Now, for the other reasons, for the other functions, for all this other stuff, that is another conversation for another time. But in the meantime, I hope that we've learned something today um, about the analemma and the gnomon and the trigonomic function of many of these diagrams and petroglyphs and all these things. Um, if you want to know more about this, you can follow us on Facebook at the, here we go. Look at that. It was a little easier to see than the other, the white behind it. But there you go. Angle of degree, amount of charge. Angle of degree, amount of charge. And there we go. We got it. And then that causes earthquakes and all the like and all the fun stuff that we've all been searching for. And it's just this simple. So yeah, if you want to learn more, if you want to follow us on Facebook, you can follow us on YouTube. I do a little bit of Instagram. It's mostly artwork. Um, but the real conversation happens on Facebook. Heathen Stargazers, the Gazing Gallery is also mostly artwork, and I also do some divination stuff. So if you're looking for that, check that place out. But for this type of thing, Heathen Stargazers, heathenstargazers.org. And that's it. That's all for today. We'll be back soon. Thanks.